Let's consider the question number 28. For x square not equal to n pi plus 1, n is a natural number, we actually have to talk about this integral. We have to integrate this expression. Okay, it includes x square root of 2 sine x square minus 1 minus sine 2x square minus 1 divided by the same term with positive sign between the two terms. So here we can see, if I consider it as theta, it is actually 2 sine theta minus sine 2 theta. Sine 2 theta meaning 2 sine theta cos theta. So that term can be taken common comfortably and can be cancelled. So let's start this question by writing it first. Let x square minus 1 be theta, that is 2x dx is equal to d theta. So this question starts as integral equals x dx becomes d theta by 2, we can write half outside, clear, square root of 2 sine theta minus sine 2 theta, which can be written as 2 sine theta cos theta, divided by 2 sine theta plus 2 sine theta cos theta multiplied with d theta. This is clear. We can take 2 sine theta common from numerator and denominator, just cancel it. We are left with 1 minus cos theta upon 1 plus cos theta inside the root sign. So integral square root of 1 minus cos theta divided by 1 plus cos theta d theta. Now 1 minus cos theta, that is 2 sine square theta by 2, 1 plus cos theta, that is 2 cos square theta by 2. So we have half integral tan theta by 2 d theta. We can integrate it, and the integral of tan theta by 2 is simply given by log mod sec theta by 2 whole divided by half, meaning 2 is multiplied here plus constant of integration. So this is clear. Let's put back the value for theta. This is log mod sec x square minus 1 whole divided by 2 plus constant of integration. Now just look at the options. We can see log sec x square minus 1 divided by 2 plus constant of integration is given as option number 3. But when you look at option number 2, it has half log sec square x square minus 1 upon 2, that is also same, meaning both options 2 and 3 are same, and these are the correct options. So this question has a bit change here. Instead of one correct answer, there are 2 correct options, 2 and 3. Definitely you must be getting a mark even you have marked 2 or 3. Let's move on to the next one, that is question number 29. If ABC be 3 distinct real numbers in GP and a plus b plus c is equal to xb, then x cannot be. Let's start this question. We can write here a plus b plus c is equal to xb, correct, or a plus c is equal to x minus 1 into b. ABC are in GP, so b square is AC. Once we square, we have a square plus c square plus 2ac is equal to x square minus 2x plus 1 into ac. This is clear. We can further rewrite this equation as a square plus c square is equal to x square minus 2x plus 1 minus 2, that is minus 1 finally, into ac, correct. A square plus c square, since a and c are distinct real numbers, so a square plus c square is definitely a positive number. So this is greater than 0. This point is clear. Next, let's look at the question again. ABC be 3 distinct real numbers with the constraint, then x cannot take which of the following values. Let's consider it. AC is actually b square, so we can write here a square plus c square is equal to x square minus 2x minus 1 into b square is greater than 0. So what's the conclusion here? X square minus 2x minus 1 must be greater than 0, or x minus 1 whole square must be greater than 2. This is clear. I repeat, x square minus 2x plus 1 taking rest terms on the other side. So here we have the conclusion that x is minus 1 whole square is greater than 2, or x minus 1 is greater than root 2, or x minus 1 is less than minus root 2. So the result says x is greater than root 2 plus 1, or x is less than 1 minus root 2. This point is clear. So from the given options we can clearly see first option, which has the value for x as 2, this is not possible. So correct answer for this given question is option number 1. So let's write it down as option 1 is the correct answer. Moving on to the next question, that is question number 30, that is the last question of this first paper of 9th January 2019 morning shift. The equation of the line passing through the point minus 4, 3, 1 parallel to the plane, equation is given, and intersecting the line, another line is given. Interesting one, let's start it. Here we can see in the solution part, we can start here itself. This line is given, let's say this is equal to lambda. Our line is intersecting with it, we can have a point on this line. This point can be considered as minus 3 lambda minus 1, 2 lambda plus 3, minus lambda plus 2. So this is one point. Let's say this is the point of intersection, meaning this point is also lying on our required line. Can we find the drs of required line? Yes. Therefore, drs, what we define? x2 minus x1, y2 minus y1, z2 minus z1. So this point as well as the given point. This is clear. So we have minus 3 lambda plus 3, right, because this one plus 4. Then 2 lambda plus 3 minus 3, giving me 2 lambda. Next minus lambda plus 2 minus 1, giving me minus lambda plus 1. These are the direction ratios of required line. This is clear. Next, this line is parallel to the given plane. If a line is parallel to a plane, meaning it is perpendicular to the normal of the plane. So normal of the plane, that is 1, 2 minus 1, my line is perpendicular to it. So we have, since line is perpendicular to normal of plane, therefore we can write 1 into minus 3 lambda plus 3. Then from the plane's normal we have the ratios as 1 to minus 1. Let's mention 1 to minus 1 plus 2 times 2 lambda minus 1 time minus lambda plus 1 is equal to 0. Simplifying, we have minus 3 lambda plus 4 lambda, that is lambda, plus lambda, that is 2 lambda. Next 3 minus 1, that is plus 2, equals 0, or lambda is equal to minus 1. This is clear. We got lambda. Now we can find direction ratios here. Let's write down the direction ratios. Therefore, direction ratios are, it was minus 3 lambda plus 3. We put lambda is equal to minus 1. So we have 6. Next minus 2. Next we have 2. Or we can write it as or 3 minus 1, 1. So these are the direction ratios. Point is given to us, direction ratios obtained. So let's check out from the given options. Point was minus 4, 3, 1. Minus 4, 3, 1. This point is not correct. Minus 4, 3, 1. This is correct. Minus 4, 3, 1, minus 4, 3, 1. So points are correct in option 2, 3, 4. Now let's talk about the direction ratios. 3, minus 1 and 1. We can see option number 3 involves all correct results. So we have x plus 4 upon 3 equals y minus 3 upon minus 1 equals z minus 1 upon 1 as the required line. So let's write down the correct answer is option number 3. So I'm sure this point is clear how this question of 3D is being solved. So this was about the first paper, that is the paper of 9th January morning shift mathematics from JEE Mains. Thank you so much.